In this lecture, we're going to talk about architectural technical communications. And by that, I mean the kind of views that we create when we want to represent our architectural ideas to people that we want to, well, either communicate the ideas of their construction or their use or how to build it. And then in the final second part of this lecture, we'll talk about the project elements that are involved in the project that we're going to work on in this module. Kind of help ground them, tell you what they look like in reality compared to what we're drawing, etc. So let's get started. By architectural technical communications, I really mean the kind of views, the concept of floor plans. If you don't know what that means, we're going to explain that in the next couple of slides, just like all of these. But we have floor plans which are looking down on the view of the building from a bird's eye, and then the concept of a reflected ceiling is looking back up at the ceiling plan. Elevations, meaning looking at the building, standing in front of it, either on the exterior or the interior of the building, looking at a wall or surface, and helps to describe what materials it's constructed out, where the windows are located, etc. Then the site plan is just the general location of the building on the site. Sections are cutting through the building in order to expose the elements that it's constructed out of and help to explain it better. And we can detail those. We call those section details, where we zoom in very close in order to really highlight some kind of specific issue that we want to communicate. And then we have drawings that we only partially participate in, and those are like the structural drawings, what displacement of the steel, and this other term called MEP, mechanical, electrical, and plumbing. And we'll do a little bit of the structural, and in environmental controls, we'll really do some look at the MEP. So let's start with the first kind of view, and that's a site plan. So a site plan, this is an example of a project we're going to do. We're going to make this townhouse with these nice patios and all this vegetation around it. And this is the site plan for that. It's not intended to be graphically rich as far as for a presentation, but technically rich. It tells everything somebody needs to know about how far it sits away from the edges of the lot, how large the lot is that it's being placed on, what streets it's located at, ideas of where the sidewalks are located, all kinds of information that would be involved in helping to establish an approval to build this building. And site plans can come in all forms. And while we're working through school and studio projects, our site plans are going to take more of the look to what we're seeing on the right here. This is like a campus plan. And you'll notice how it's graphically very rich and clear. And on the left, we have a technical plan. This is a site plan, also a site plan, but it's a site plan for the location of a home or residence on a site, and it indicates the distances from the lot lines around. And this would be used in the filing of a building permit. So the one on the left is for, let's say, filing for a building permit, and the one on the right is maybe to make a community presentation about why we're locating the building in the campus the way we are. Plan views are a place where we'll spend a lot of our time, and I want to make some clarifications about how that works. It is a slicing through the building at a 4-foot level, and I have a way to visualize that in the next slide here. This is a project we're also going to be working on. It is our building. We're going to start that in this module, but I've made a red line around it, and that indicates a 4-foot level that we've cut through the building. So no longer are you seeing the roof or anything above that, or even the ceiling plane, but you're just seeing everything from there down. And when we take that building and rotate it, so we're looking directly down top of it, as I've illustrated on the left here, you'll notice how things have certain kinds of appearances. We see all of the countertops and surfaces, so we know where people would be seating. We can see all the fixtures in the bathrooms. We can see the doors for what they are and how they have a thinness to them. The same way with the windows, we can see the mullions and the sheets of glass. And if we were to take this view, this graphically model view that has perspective to it, you'll notice how the lines taper in, and we made it orthogonal, which I'll explain to you in a couple more slides, meaning it has no perspective. It looks very much like a technical floor plan. And so it's just important to note, and I'll go back to this slide, that typically when we look at a floor plan, we're cutting through the room at the 4-foot level and only including things from 4 foot down. And we pick 4 feet because that's above the level of countertop height. So that allows furnishings to show within the drawing that we're creating. Elevations are another form of view. It's the elevation meaning going vertical, like an elevator. It's the vertical look of the building, typically the facade. You'll notice on the left here, I have an indication of what's the typical arrangement. When you place a drawing on a sheet, the north is typically to the top. So if you were looking at a south elevation, that would mean that you're looking from the south to the north, and you're catching the south side of the building. And all of these relate back to, and I probably didn't make that completely clear. If I was to go back to the plan view, this is the project browser inside of our BIM modeling environment, Revit. And so the floor plan is listed as a level, and we have ceiling plans, we have elevation views, we also have 3D views. So we have a whole assortment of views that we will make reference to while we're working on our model. So sorry to flip forward like that so quickly, but then, so here we have that same interface on the right here, and you can see the elevation, the building elevations to the north, east, south, and west. Pay particular attention to this elevation. It's really a very attractive one. It is a very simple one. The trees are ghosted out. There's nice line weight. You get an idea of the change in the topography, the level of the soil that goes around the building. We get a little shadow under the windows to indicate that they might be recessed. There's a little what we would call poching, or an effect of the materials that the building is constructed of. Another form of building drawings is the wall building section. It's a detail of cutting through the building. And once again, when we generate those in our BIM modeler, under the project browser, sections will automatically start to be developed as we cut sections. And so it'll start calling it section 1, section 2, etc. And so now the drawing I'm over right now, moused over, is a whole building section. And then on the right are building detail sections. So we've zoomed in very close here in order to indicate certain kinds of construction details that are critical to somebody who would want to build this building. We also have that idea of 3D views, or views that show our model as a three-dimensional object. And it's important to become familiar with a couple of ideas. One is perspective. The other one is orthographic. Perspective means that lines change, like the vertical line on the elevation of a building from the front to back will change. There'll be a compression as it moves away from us. So if I was to, I guess, visualize this idea of perspective, we have on the top here, on the top left, a wood framed wall. And you can notice how we know that the wall is really a level wall. We're not making an angled wall, but the wall is receding away from us. And it's done in a fashion which is called two-point perspective. There are two vanishing points, as illustrated on the bottom left here by this drawing. And there's also the concept that if we really focus on one single vanishing point, it's called one-point perspective, we can still generate a lot of three-dimensionality to the image, at the same time that we don't have to have the front elevations of our buildings have that kind of perspective to them. So this is just another way of visioning perspective. In our software, we don't actually generate one-point perspective. We're always working in the model space that generates really a two-point perspective. But if we move very closely, if we focus on just shooting towards the single vanishing point, our drawing will appear to have one-point perspective. This is an illustration of why perspective is really important to us, the idea that we can create perspective. This is a view of the building that we will be creating, and we're looking at it from the same vantage point. And I've changed two settings in the software. One, I've said look at it from the camera view and the perspective, and now you'll notice how components of the building that are equal height become shorter as they get further away from the viewpoint. So we have, and these are both moving in a two-point perspective here. And then if I turn that perspective control off, we're looking at a building that's now presented in what's called an orthographic way. So there's no perspective, so we have no visual clues about whether something is near or further away from us. And I think in general, it's very quick to realize that perspective gives us a whole lot of new information about the shape and volumes of the architecture that we're making. So it's important to remember those two terms, perspective and orthographic. We'll start now in the next clip, and I'll break it off, and we'll start talking about the projects, the components that are going to be in the project that we're going to be working on.